Programming means abstracting the real world into your programming language. In other words, modeling the real world into a programming language. And this process is known as abstraction. You will understand more in this video when we do our first program. So what we're doing is we are trying to calculate the coordinates of the antipode point for a point on the Earth's surface. So let me show you Google Maps here. Let's say we want to know if we were to dig a tunnel under Madrid going towards the center of the Earth, where would that tunnel exit on the other side of the world? Well, we can calculate that in Python using a formula. Because if you know the coordinates of Madrid, and you can know that by right-clicking over Madrid on Google Maps and go to what's here, and you'll see that these are the latitudes, so 40.22 and minus 3.55 is the longitude. By knowing these coordinates, we can calculate the coordinates of the antipode point. We know that from the previous video, the antipode for Madrid was actually this island in New Zealand, which actually happened to have a coordinate of minus 39. So Madrid had a coordinate of 39, and this here has minus 39 because the latitude that passes through Madrid has a value of around 39 plus 39. This equator here has a value of 0, so 39 here. The opposite is minus 39, which passes through this island in New Zealand. And then we have the longitude. So the longitude of Madrid was around minus 3.6. And the longitude of New Zealand is 175. Around that. So there's a difference of 180 between the two longitudes. I'll tell you the exact formula, but I'm just trying you to understand the real world problem. So we're still in the real world now. Then we will abstract this problem into a computer programming language such as Python. So the longitude with a value of 0 passes through United Kingdom here. And Madrid happens to be 3 degrees to the west. So going to the east, the longitudes change up to 180 degrees. So plus. All these longitudes here are plus. 180 is here. Then if we go to the west, starting from this 0 longitude that passes through United Kingdom, the values are negative. So minus 10, minus 20, and so on and so forth, up to minus 180. So negative to the west and positive to the east. So our program will get some input and will produce some output. The inputs will be these 2 coordinate values, and the output will be another 2 coordinate values. Well, the latitude is 40.09. So now start the process of abstraction. How do we represent this value in Python? Well, Python is made of objects, and these objects have a type and they have attributes. In this case, this number is actually an object, this latitude. And I said that there are different types of objects in Python. So for this object, since this is a decimal number, we need to find the correct representative object in Python for decimal numbers. And that is a float. That is the syntax to create an object. Inside those brackets go the attributes of the object. In this case, it is 40.09. And that is our first object in Python. So why did I choose float and not another type such as int? int stands for integer, and it is an object in Python, a Python object to abstract whole numbers. So we have whole numbers in the real world, such as when you count the eggs in your basket, you'd use a whole number. You wouldn't say there are 3.76 eggs, you'd say there are 4 eggs or 3 or 5. So if we were to make a program with eggs, counting eggs, or I don't know what you can do with eggs, then you'd use an int object type with an attribute of 4 or 5 or whatever whole number that you like. Even negative numbers such as -4 and 0 as well. This is not the case here. We are talking about decimal numbers. Now, just one thing here. We could have just typed in 40.09 directly without typing in float and without typing the double quotes around the number, as we are currently doing. And in fact, every programmer would use the short version, so 40.09, and we will do that too eventually after this section, but in this section we will do things the long way. Why would we do that? Well, because you'll understand Python from a deep level, because when you type 40.09, as we will eventually do later, the Python interpreter translates that 40.09 to float, open parentheses, double quotes, 40.09, double quotes, close parentheses, in the background. We don't see that, but that's what Python does. And so knowing how Python does things will give you a deep understanding of Python from a deep structural perspective and not simply from a superficial syntax level. Similarly, you will see in this section that we don't use, for example, 3*4 to multiply two numbers, but we would use a mul method, which stands for multiplication, to do the multiplication, which again is a long way, but it is what Python uses in the background. So to wrap it up, in this section you will learn some Python secrets that no other course covers. And let's carry on with our example now, where we left. Now, a Python program contains different lines, so you separate things in different lines. Here what we do is we get the longitude now. We have another object in the real world, so it's a longitude on the Earth's surface. How do we represent it? Well, the same way, using a float object type. Inside we put its attribute, -3.47. So I'm just using 2 decimals after the dot, after the decimal point, because I think this is enough for our purpose. So this is a process of abstraction. Now, I know some of you are thinking, oh, why don't you just write the numbers directly without using a float name there, without using those quotes? Well, I'll get to that in the next videos. You'll understand why, so please stay tuned. So this is enough information for this video. What we did in this video is we created 2 objects. The first object was this one in here. The type was float. That part is the type of the object, and this part here is the attributes of the object. 40.09. The attributes go inside quotes, and the same goes for the other object. Let's learn about identifiers in the next video.